Well, let's talk about how Aroaro network data visualization works. Aroaro can display a network dataset because it creates a 3D graphical representation of the connectivity information in the data. This means Aroaro builds a graph, and in order to see it, we use the following attributes. First one is color. Color can be applied to categorical attributes. A node is a categorical attribute.
Let's apply the color function to the type. It seems there are two different types in the carrier network, because there are two different colors, one is blue and one is red.
All right, the second one is saturation. Saturation can be applied to numerical attributes. Any network centrality measurement is a numerical attribute of a node.
We could apply the saturation function to the degree value. And the deeper color will represent the higher value, and the lighter color will represent the lower value of degree. So it seems this node has the highest value of degree because it has the deepest color.
That degree is 41. The third is label. On the right-hand side, we can see how to turn it on and off. The user is able to turn on labels for all nodes. And on the left, let's see the labels Aroaro uses. The user can only select one attribute to be shown on the label.
If I apply label to degree, which means I only show one attribute that is degree on each label, we can fly to it and look at label. And if you want to look at more information about this node, you can just easily explain it and look at more attributes regarding this node.
Great. With the main function explained, let's now turn our attention to how visualization and immersive analytics interplay. We all know now that a network consists of nodes and links, just like people and friendships. This is an example of a network that consists of influencers and other members of a social media platform. The blue color is used for influencers, and the red color for other network members. We want to find the most influential people in a social network. We can use measurements of network centrality to make such decisions. Those measurements typically refer to degree, closeness, and betweenness. So perhaps someone with the highest number of friendships. This would mean that this individual has a high degree value.
Let's apply the saturation to degree. It seems this node has the darkest color, which means it has highest value of degree. Let's fly to it.
Yep, confirms the highest degree is 41. Or someone who is closest to all other nodes in the network. This would mean this individual has a high closeness value.
Let's apply saturation to closeness. So we can see there all nodes have higher value of closeness compared to the degree value. But it seems still the same node who has the highest value of the closeness.
And the value is 0.5882. Or someone who acts as a bridge between communities in the network. This would mean this individual has a high betweenness value.
So I apply saturation to betweenness. And only few nodes have higher value of betweenness, and still the same node has the highest value of betweenness.
And the value is 0.1769.
combine these three measurements, I believe that this node is the most important node in this current network.
Great. Next, what if, using any network centrality measurement, we just found more than one candidate and have to choose one of them? In other words, we have found influencers who are highly influential, according to the centrality measurements. For instance, node 50 and node 57.
So this one is node 50. And that's node 57. Looking at these two nodes, and it seems they all have the same value of degree, but node 50 has higher value of closeness, but node 57 has higher value of bitterness. So which node is more important in this case?
Remember, we need to choose one. But if the measurements are not able to tell us, what else can we do when the analytics are not able to afford such basis for my decision? Can we walk around the network and discover features that only 3D visualization can afford? This is the fundamental question of our current research on network data visualization.
So currently, I apply saturation to all nodes. I apply degree to this node. And let's observe the node 50 first. So we could fly around and observe all the connection of neighbors of this node. So it seems the node 50, the neighbors of node 50 all have the lower value of degree. So seems the neighbors is not important. So let's look at the node 57. It seems the node 57 connect to more important node. So do you guys remember this node is the most important node in this network?
So you just found that node 57 is a neighbor or a very important node according to degree, but that doesn't happen with node 50.
So in this case, I may determine the node 57 is more important by observing the neighbors in this network.
All right, so we have chosen node 57 based on further insight into the network using our 3D tool. Decision makers may have exhausted the decision-making criteria. However, they might get a sense by visualizing data in our mixed reality environment. They could have used other means, for instance, a 2D flat screen visualization tool. However, this can only provide a limited perspective. Compared to 2D flat screens, users are able to visualize data in Aroaro while flying into the network and observe data from different perspectives. This enhances the understanding of data and improves the quality of decision making. We want to invite you to try Aroaro or visit our lab.